6 western states, including Colorado, have agreed to make big cuts when it comes to getting water from the Colorado River. That river is facing extreme drought conditions.
The recent announcement from the United States Geological Survey, USGS, has sent shockwaves through scientific communities and the broader public alike. A red alert issued after the discovery beneath the Colorado riverbed has turned a spotlight on one of the most iconic waterways in North America. This isn't just a warning of temporary concern, it represents a potentially transformative moment in how experts view the geological stability of the American Southwest. The Colorado River, which has carved the Grand Canyon and supplies water to over 40 million people, may now be at the center of a growing crisis hidden deep beneath its tranquil flow. Before we start, hit the like and subscribe buttons for more exclusive news. For decades, the Colorado River has symbolized both natural beauty and vital resource management. Stretching over 1,400 miles from the Rocky Mountains to the Gulf of California, its waters are integral to agriculture, energy production, and drinking water for major cities such as Los Angeles, Las Vegas, and Phoenix. However, a recent USGS investigation, using deep penetrating seismic imaging and satellite gravimetric surveys, has revealed something deeply unsettling: massive subterranean voids and geological anomalies directly beneath key segments of the riverbed. These anomalies suggest underground instability, potentially related to shifting tectonic stresses, volcanic chambers, and accelerated erosion within fault structures that had previously gone undetected. What set off alarm bells for the USGS was not just the existence of these anomalies, but the rate at which they appear to be evolving. The advanced instruments used in the survey detected a sudden increase in seismic microtremors, tiny vibrations imperceptible to humans but indicative of geological movement. Initially dismissed as background activity, the data eventually revealed an organized pattern stretching for dozens of miles along a particular stretch near the Utah-Arizona border. These microquakes correlated with abnormal ground swelling and unexpected hydrological behavior, including spontaneous geyser-like bursts and temperature anomalies in groundwater readings. Further compounding the concern is the presence of mineral signatures associated with deep magmatic activity. These include traces of sulfur dioxide, radon, and other volcanic gases seeping through newly formed fissures in the surrounding rock. While Colorado is not traditionally known for significant volcanic activity in modern times, the larger Colorado Plateau, on which the river flows, has a history of ancient eruptions and tectonic uplift. This region has long been geologically active, shaped by the same forces that form the Rocky Mountains and the Basin and Range Province to the west. What makes the current discovery so significant is the way it appears to merge several geological threats into one evolving scenario. There are indicators of subsidence, where the ground above an underground void gradually collapses, alongside signs of increased pressure from below, which could hint at the slow resurgence of a dormant volcanic system. Although there has been no eruption in recorded history in the area, the chemical evidence now rising to the surface suggests that the deep crust beneath this part of the country is not as dormant as previously believed. This realization has major implications for infrastructure. The Colorado River isn't just a natural wonder, it's also a superhighway of utility and transport. Massive hydroelectric projects like the Hoover Dam and Glen Canyon Dam rely on the river's predictable flow. If the underlying geology were to shift significantly, even by a few inches over time, the structural integrity of these dams could be compromised. Cracks in the foundation or lateral movement in the bedrock could translate into mechanical failures in the turbines, or worse, structural fatigue in the dam walls themselves. Moreover, many pipelines, bridges, and roadways intersect with the river or lie close to its path. A destabilized riverbed could translate into sinkholes, landslides, and infrastructure collapse. The USGS findings have already prompted preliminary reviews of safety protocols for these installations, though no immediate public danger has been declared. Still, the issuance of a red alert is not taken lightly. It is the highest level of geological warning the agency can issue short of an active eruption or catastrophic quake. The red alert status underscores the urgency with which scientists are trying to model potential outcomes. Hydrologists, seismologists, and geophysicists are collaborating on simulations that take into account not just what is known, but what is still uncertain. One possibility is that the anomalies could trigger a slow, creeping deformation that disrupts the flow of the river, potentially altering its course over years or decades. Another, more concerning scenario is that pressure from below could lead to a sudden event, such as a hydrothermal explosion or a localized collapse, that could have immediate consequences for communities and ecosystems downstream. Adding a layer of complexity is the river's relationship with the surrounding aquifers and groundwater systems. The Colorado River's flow interacts dynamically with the porous layers of sediment and rock that surround it, recharging and being recharged by underground reservoirs. If the underlying strata are shifting or becoming more porous due to heat, pressure, or gas intrusion, this could spell trouble for the already stressed water supply of the Southwest. Aquifers could become contaminated, depleted, or rerouted entirely, leading to a domino effect on water availability. Ecological consequences are no less dire. The river supports countless species of fish, birds, and mammals that depend on its seasonal rhythms. A destabilized riverbed could alter those rhythms, potentially destroying breeding grounds, altering migratory paths, or causing toxic gas release into the water. Already, biologists monitoring the area have reported unusual behaviors in aquatic life, including mass fish movement and unexplained die-offs in small tributaries. Climate change adds another dimension of uncertainty. The entire region is already experiencing prolonged drought conditions that have reduced the river's flow and exposed its vulnerability. Combined with these new geological findings, the implications of a rapidly changing climate become even more dangerous. If a major geological event were to coincide with extreme weather, such as floods or heat waves, the compounded effects could overwhelm emergency response capabilities and devastate already fragile ecosystems and infrastructure. One of the more controversial theories emerging from this discovery involves the role of human activity in triggering or accelerating the changes beneath the riverbed. Over the last several decades, excessive groundwater pumping, oil and gas extraction, and even deep waste injection have altered the subterranean pressure balance of many areas in the American West. While the USGS has not officially attributed the anomalies beneath the Colorado River to these activities, some independent experts suggest that anthropogenic influence cannot be ruled out. Altering pressure gradients, even at a distance, can trigger chain reactions deep underground, especially in geologically complex regions. Geopolitical tension over the Colorado River's use is likely to increase as the implications of the USGS findings sink in. States already locked in fierce negotiation over water rights may find themselves dealing with a new, much more unpredictable variable. If the river's course were to change, or if its capacity to store and deliver water were compromised, the current legal framework for its use could collapse. Treaties, compacts, and agreements, some dating back over a century, would no longer be viable, potentially triggering a wave of litigation and political disputes. One of the more chilling aspects of the discovery lies in the parallels it draws to other geological events in recent history. In 1980, Mount St. Helens gave subtle signals before erupting catastrophically. The activity began with small quakes and gas emissions, which were initially downplayed. In that case, a dormant system proved far less dormant than expected. While no one is suggesting that the Colorado River is hiding a future Mount St. Helens beneath its bed, the idea that long, quiet geological systems can awaken with relatively little warning is gaining new traction among researchers. Public reaction has ranged from alarm to disbelief. While government agencies have attempted to manage the narrative by emphasizing the ongoing nature of the research and the lack of immediate danger, the red alert status cannot be easily brushed aside. Community meetings in towns along the river have seen growing attendance, with residents asking pointed questions about emergency plans, evacuation routes, and the safety of their homes and water supplies. Many are now pushing for independent monitoring and access to real-time seismic data. Behind the scenes, emergency preparedness agencies are reviewing and updating their response protocols. Although the event that might trigger a crisis is still hypothetical, agencies like FEMA and local disaster response units cannot afford to wait until that moment arrives. Pre-positioning of resources, updating hazard maps, and refining evacuation drills are already underway, especially in vulnerable regions like Lake Powell and Lake Mead, where millions of people rely on the river's consistent behavior. The scientific community, meanwhile, is racing to gather more data. New drilling expeditions are planned to sample rock and gas directly from the anomalies. Airborne LiDAR and thermal imaging drones are being deployed to monitor surface changes, while satellite radar systems continue to track deformation on a scale of millimeters. This is science on the edge, attempting to understand a complex, multi-layered system that may be tipping into a new phase. At the heart of this unfolding situation is a fundamental shift in understanding. The Earth beneath the Colorado River is not a static foundation, but a dynamic living system. It responds to pressure, heat, time, and even human interference. For generations, it has shaped the landscape without noticeable protest. Now it appears to be making itself heard, not through a dramatic explosion or quake, but through a whisper of tremors and the faint scent of sulfur rising from the depths. In the weeks following the issuance of the Red Alert, the scientific momentum surrounding the Colorado River anomaly has only intensified. Researchers from institutions across the United States, including Caltech, the University of Utah, and the National Center for Atmospheric Research, have dispatched field teams to remote sections of the riverbed. Their objective is singular, but urgent: collect as much empirical data as possible before the geological window shifts again, potentially closing access to the newly exposed signs of subterranean volatility. One of the most critical new discoveries came not from the original seismic data, but from thermal spectroscopy conducted via high-altitude drone flights. Over a previously undisturbed segment of the river near Marble Canyon, scientists detected a clear and consistent thermal anomaly, one that diverged sharply from surrounding readings. These elevated temperatures were not superficial. Rather, they extended deep into the underlying strata, indicating a vertical movement of heat likely caused by pressurized geothermal activity. This kind of subsurface heating, especially in areas with no known hot springs or hydrothermal features, is often associated with magma movement or hydrothermal convection, a sign of dynamic changes miles beneath the surface. The thermal imagery also revealed circular patterns and small domes forming in the landscape near the river's edge. These structures, only visible from the air and barely perceptible to the naked eye on the ground, bear similarities to uplift zones seen in places like Yellowstone and Long Valley caldera before significant geothermal shifts. Their presence near the river suggests the rise of heat and pressure in a fashion previously undocumented in the region. These new formations point to the possibility of a slow, bubbling inflation of the crust that could, over time, lead to sudden ruptures. Complementing these observations are gravimetric readings taken by the Gravity Recovery and Climate Experiment follow-on GRACE-FO satellites, which have shown subtle but distinct mass redistributions beneath the Colorado River basin. While these satellite instruments were originally designed to track groundwater depletion and glacial mass changes, their precision has proven invaluable in revealing where underground densities are shifting. Over the last 6 months, GRACE-FO has recorded a reduction in mass in some areas, indicative of cavities or voids forming, and increased mass in others, likely where magma or fluid pressure is accumulating. These dynamics provide a 3D image of geophysical change that had gone unnoticed for decades. To understand what might be causing this movement, scientists are diving into the geologic past of the Colorado Plateau, a region with a complex history shaped by both tectonic extension and ancient volcanism. The area is riddled with deep faults and fissures that formed during the Laramide orogeny and later rifting episodes. Though most of these structures have remained quiet for thousands of years, they now appear to be reawakening. A recent magnetotelluric survey, measuring the Earth's natural electric and magnetic fields, uncovered zones of unusually low resistivity, a hallmark of fluid-saturated rock or molten material. These conductive anomalies form corridors that seem to channel energy and material across vast distances, linking different sections of the riverbed in an invisible web of connectivity. What's perhaps even more unsettling is that some of these underground networks stretch dangerously close to urban areas. A particularly active corridor appears to run westward toward the outskirts of St. George, Utah, and another arcs south toward the greater Phoenix Basin. Though deep underground and not yet posing an immediate surface threat, any escalation in pressure along these conduits could theoretically bring new risks to these growing metropolitan zones. Engineers and urban planners are now being urged to revisit their geological risk assessments and reclassify zones of potential instability based on this unfolding body of knowledge. Amid the technological analysis, a quieter but no less important story is emerging from local communities and indigenous nations whose histories have always been tied to the land. The Hualapai, Navajo, and Hopi peoples have long shared oral histories that speak of the earth shifting its bones beneath the Colorado River, ancient tales that describe ground rumblings, sudden floods, and unnatural warmth in the earth. While often dismissed as mythology, these stories are being re-examined in a new light. Ethnogeologists, who study the intersection of indigenous knowledge and earth science, are working with tribal elders to compare these oral traditions with modern data. Preliminary correlations are remarkable. Areas described in old stories as forbidden paths, or places where the water boiled without fire, correspond strikingly with zones of increased geothermal activity now being monitored by satellites and ground sensors. These human connections to the land bring an added layer of urgency. For the tribes who live near the river and depend on its flow not just for survival, but for spiritual identity, any change to the river's path or behavior is more than environmental. It's existential. As such, a growing coalition of tribal scientists and cultural leaders is demanding inclusion in both the monitoring and decision-making processes that follow from the Red Alert. This may reshape the role of indigenous governance in geoscientific policy across the Southwest. Another fascinating dimension is the impact of the anomaly on groundwater chemistry. Independent labs analyzing samples from wells near the affected zones are reporting a change in mineral content and gas saturation. Elevated levels of boron, lithium, and even rare earth elements have been detected, suggesting a deep source is seeping into upper aquifers. More concerning, however, are the traces of hydrogen sulfide and carbon dioxide, gases typically associated with volcanic or hydrothermal systems. These gases can acidify groundwater, erode piping, and in extreme cases, become lethal in enclosed spaces. The sudden appearance of these gases is being treated with seriousness, especially after several incidents in the past where geothermal gases led to asphyxiation hazards. Though no casualties have occurred in the Colorado River region, warnings have been issued for workers in well drilling, tunnel construction, and hydropower maintenance to wear gas sensors and remain vigilant. State agencies in Arizona, Nevada, and Colorado are deploying new safety guidelines and response plans that reflect the changing subterranean reality. The presence of mineral-rich fluids also raises broader questions about long-term resource management. Some mining interests are eyeing the potential for extracting lithium and rare metals from these geothermal sources, a move that could spark a regulatory debate balancing environmental risk against strategic material demand. As the United States seeks to reduce its reliance on foreign rare earths, discoveries like this could become flashpoints for ecological and political contention. Meanwhile, the river's sediment load is being affected in strange and unexpected ways. Turbidity levels have spiked in certain segments, even in the absence of upstream rainfall or dam releases. Scientists believe that internal sediment surges, caused by destabilization of the riverbed from below, may be responsible. These silt pulses can smother aquatic life, interfere with water filtration systems, and reduce storage capacity in reservoirs by accelerating siltation. The frequency of these events is being closely monitored, with specialized sonar and turbidity meters now installed along key choke points like Glen Canyon and Black Canyon. Beyond the physical implications, the Red Alert has sparked philosophical debates among scientists and thinkers about how modern societies interpret geological time and stability. The apparent permanence of rivers, mountains, and valleys is largely an illusion imposed by human lifespans. Yet in the Colorado River, people are now witnessing changes occurring not across millennia, but within mere months. This temporal acceleration, driven by natural and anthropogenic factors, challenges the assumption that the Earth changes only gradually. It's a humbling realization, one that has scientists rethinking models of risk and resilience. Perhaps one of the most debated topics in the geophysical community is whether this Red Alert event could be a precursor to a phenomenon known as an intraplate rupture, a rare but catastrophic type of seismic activity that occurs far from tectonic plate boundaries. Such facilities are costly and logistically challenging, but may offer the best chance of catching early warning signs before a major event. Discussions are underway between federal agencies, academic institutions, and private partners to fund and deploy the first of these boreholes within the year. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on the USGS red alert beneath the Colorado riverbed? We want to hear from you. Thank you for watching, and see you next time.